Good morning, everyone. Thank you for inviting me here to speak with you all today. I apologize for my lack of Portuguese. My name is Brooks Patrick. I'm with Esri, and I'm responsible for local government here in Europe. And I'm actually based out of our Rotterdam headquarters, working closely with our R&D centers across Zurich, Stuttgart, and many other locations in Europe. So I want to apologize ahead of time for bringing our Dutch weather here to your beautiful city. When I was preparing this presentation, I thought about one thing we all have in common. We use GIS to make an impact on the world around us. And more is the case, we see GIS being used to create and manage digital twins across many different scales, across many different industries. Digital twins have many representations. They allow us to predict in the physical world by modeling the physical world in the digital world. And these are becoming increasingly complex. We're starting to make more and more copies of the world. And digital twins have the potential to add tremendous value to your work, also preparing us for the AI revolution that's underway. And many of you are investing in digital twins today. And I'm here with a number of examples to argue that GIS offers a framework for not only creating a digital twin, but managing it and applying a digital twin across many different use cases. Digital twins are abstracting and modeling everything, but they always have to be based on a specific use case. It's not one digital twin, but many digital twins, which are defined by the business challenge, not by the data. The data itself can be shared across many of these use cases, across many different applications and experiences. And that said, reality mapping and data integration is a key aspect of how we build, operate, and maintain these individual environments. So what does this really look like? The maps we create are gradually, increasingly becoming closer to reality itself, and they're not only realistic, but they're true images of reality, able to model and describe the relationships within cities. This is what we call a digital twin. Reality mapping can result in a 3D mesh like the one you see here in Stuttgart, and it offers the foundation from which you can start to overlay your existing GIS data and make use of that information in a more immersive environment. It's a very simple concept, but I do want everyone here to understand that this just works with your existing GIS. And as BIM is used more and more throughout the architecture, engineering, and construction sectors, this data too can be brought into the digital twin. This example here is Stuttgart 21. It's one of the largest railway station renovations in Germany. It's also highly controversial. This is an ongoing partnership between Autodesk and Esri to make it easy to start integrating this very highly detailed information into your GIS, upping the fidelity of your overall base map, and we can start to make use of this high fidelity data because when we bring that into our GIS, we're retaining all of that metadata with it. These digital twins can also be used to run real-time simulations, looking at flooding, for example, whether it's major rain events or maybe river event flooding. With a digital twin, we can also extract information, whether it's cars, trees, and this can all be done with that imagery that we're capturing. The way we experience our GIS information is also rapidly changing. Expectations are essentially catching up with reality. Game engines are offering a more experienced, immersive view of our data, and they're being used in emergency response planning, urban planning, which you'll see in one of my examples, and many other fields. And this is following the same pattern that Esri has with web maps. We can stream this information dynamically into game engines, going away from more the one-off projects that maybe many of us have done with these game engines. And with the latest hardware, for example, Apple Vision Pro, this really allows us to place ourselves in the map. And digital twins are being applied for urban planning, for example. And what used to be 2D master plans or large development plans with very complex rules and regulations, these are now being more and more flexible and as an environment from which we can start to do scenario design on our future cities. This is combined with increasingly more accessible analysis tools that are inherently 3D, such as ViewShed, so that we can understand the impacts of these decisions not only on number of apartment units, et cetera, but also we can understand if it's going to block our important views. And BIM information is going to play a vital role in how we start to understand and judge the merits of inbound development proposals. Not just in urban planning, but also when we talk about network management. A lot of these two-dimensional data sets are now being transitioned to three-dimensional data sets, where we start to see the z-value get included and integrated into the core data. This is allowing us much greater accuracy when it comes to digging and looking at underground information. Above ground, same thing. With this higher resolution information, we can start to run more advanced analysis, like noise analysis, which is inherently a 3D problem, and understand, especially in hilly environments, where noise will be impacting the most in our urban fabric. Also wind. Using ArcGIS Pro, wind analysis can be used to understand not only how it performs today and where we have troubling locations, but also in the future, when we start to propose higher and higher buildings. How will that impact the wind patterns across the city? And recently we've added to ArcGIS Pro real-time flooding simulation. I showed a little bit of this earlier, but this is allowing us to basically run scenarios of mitigation, but also scenarios looking at the parameters that are, let's say, assumed with that type of natural disaster in this case. In this case, looking at river flooding in the capital of Slovenia. So digital twins support many scales, from the region to the cities to large facilities down to the site. And I hope many of the examples I will go into will help you visualize how this could be applied to your work. Within all of the examples that I'm going to be showing you today, what they all represent is a distributed GIS architecture, and this is resulting in a sort of geospatial infrastructure for cities. And this in turn is transforming how different departments in a city or city to regional authorities work together, sharing resources, content, maps, models, different workflows, improving how we collaborate by sharing data services rather than making data copies. And this is being embraced by thousands of organizations, both in the public sector, but also the private sector. This is because Esri is also committed to an open and secure architecture. We're basing this entire platform on internationally recognized open standards, and this means that there's no vendor lock-in. So many of the examples today are more modular examples, and they all adhere to FAIR principles: findable, accessible, interoperable, and reusable. And this is a decades-long commitment of Esri to the open source and open standards community. So I will take you through 4 examples today, each one a different scale and a different set of use cases. And hopefully some of these can be patterns that you yourselves can adopt. Let's start with the regional digital twin. And for this, I'll take you up north to North Rhine-Westphalia, and this is the state authority in northwest Germany, very close to the Dutch border. North Rhine-Westphalia has a digital twin focused on providing the data they need for responding to natural disasters and other emergencies within the state. This is from fire response to flood response and more. This is a regional data set. It was published on their portal, but is also available not only internally for the different authorities, but also publicly available. This used orthographic imagery with significant overlap, and they basically bypass the need for oblique imagery capture. So the resulting 3D mesh that you can see here is just with orthographic imagery. You can see the city of Cologne, the city of Dusseldorf, and it's highly detailed. It's 5-centimeter resolution, and this is integrated into their existing emergency response web applications, where points of interest such as schools, hospital facilities, and more can start to be overlaid. And this is an important concept without having to make any changes to the existing data sets. So those agencies working on maintaining and updating all of those data sets, let's say the schools and how many students are present, this is happening and nothing needs to change. It will just work with this new application. So this is also being brought together with existing semantic 3D models, as you can see here, and tools that enable the first responders to go in and, for example, here, accurately measure and confirm the situation on the ground before they bring a fire truck, for example, that might have a ladder that's too short to reach a certain level of a building that might be in need of evacuation. This is also being used for flood event planning. This is an image here showing the very bad flooding that occurred in 2023. Imagery and remote sensing. So ArcGIS offers a complete system for imagery and remote sensing from the reality mapping phase onwards to analysis, for example with GeoAI, which you'll see a lot in my upcoming example, to the visualization of that data in downstream products like 3D Mesh. Now, whether it's satellite or airplane or drone or vehicle, it doesn't matter. Reality mapping with ArcGIS Reality is now transforming how both cities, regions, and our partners map and understand the built environment. The way we capture data today is only getting better. The detail is only going up. And with high-resolution imagery coming in, we also have developed new ways of processing the data. So I wanted to ask the audience here today, who has heard of a Gaussian splat? Okay, one person. Maybe I can't see the back row. So this is a very useful presentation for many of you. A Gaussian splat is essentially not relying on the geometric models that are often represented in a 3D mesh. In essence, this Gaussian splat is a new way of representing 3D scenes, and you can think of it as like a cloud of small, fuzzy blobs, or Gaussians as they're called, instead of polygons. Now, here you can see the city of Utrecht. This was a Gaussian splat layer that was created in ArcGIS Reality. And you can see the resulting visualization is extremely high quality in the representation of small objects like pipes, railings, and trees. Each splat is like a tiny ellipsoid of probability, and its position, shape, orientation, color, opacity is all managed in real time. Transparent surfaces are nearly true representations. That's something that really sets it across from when we look at mesh. This Gaussian splat layer was obviously created in Reality, and you can use it in ArcGIS Pro 3.6 today. And soon, you'll be able to publish these and view these in the web and across ArcGIS. Now, imagine we take this reality mapping and we combine it with advances in GeoAI. So you're able to take any imagery, whether it's DSM, True Ortho, and you can start to apply GeoAI to conduct feature extraction, identification. You can start to create a semantic model based on this underlying imagery data. Now, this is expanding not only the 2D mapping capabilities, but also allowing us to expand our 3D mapping by allowing this to be applied at scale, not only for a city, but for entire countries or regions. The city of Vilnius is the capital of Lithuania, and it's one of the leaders in applying GeoAI together with reality capture through an extensive drone program. The city has a fleet of autonomous drones. These drones, or they call them drones in a box, are located across municipal buildings in the city. And periodically, as you can see in this video, they fly and they monitor sites throughout the city. And that information is then brought back, downloaded, and used within a number of use cases that they have. The first one is to monitor waste containers. There was simply no other way to do this, to continuously monitor over 200 sites, and sometimes these sites change. Different sites have problems, so they have to retask these drones. And it's much easier to do that with drones rather than people driving around. And the objects deemed irregular can be automatically identified, severity can be detected, and this is assisting with the workforce tasking that actually has to go out in the field. This process was also deployed for roof condition inspections. The 3D models were made to reconstruct the roof, and then the statistics were used to guide inspectors that go out in the field. Here in the Lithuanian winter, which I hope you will never experience, this process helps to create a situation where roads are clear of snow. In the summer, the same system is then used to ensure that public areas are mowed properly and the grass is cut. and more. So they do much, much more. When the imagery is down to a centimeter in resolution, GeoAI can assist in road crack detection and support surface maintenance. Illegal parking can be enforced, and traffic flows can be optimized. So as Rui was saying, GeoAI is really only the beginning. And as you've seen, many products are being enhanced with AI. The AI assistants are now available to make workflows easier and more intuitive. The ability to create AI agents of your own is also on the horizon. I know this is in very early stages, but I want you to imagine that it will be similar to using Experience Builder to build apps. In a way, you will have a sort of builder experience soon for these experiences. Maybe an agent will be tasked to identify problematic sites, but then another agent will be tasked to help prioritize what that agent finds. So you can think of this as a sort of builder experience. So AI brings automation, that's clear. It brings new analysis capabilities for finding patterns in our data, and productivity, making it easier and faster to do our own work. But I would ask everyone here, imagine for a minute now a world without AI. And I would ask you, how many trees are in this photo? Right, 100, 500? Would you spend all day counting these? I mean, I remember the digitization that we used to have to do, and the correct answer is 7,215. So these workflows are not replacing our jobs. These workflows, as you've seen in all the examples, are making what we do already much more valuable, much more easy, and faster. So ArcGIS will continue to develop as a geospatial AI platform, and in the next years, you will see some amazing advancements enabling agentic workflows. The third example today brings us down to the campus, the facility scale. So we've gone region to city, now we're going to the campus, and this is the Swiss Federal Institute of Technology, ETH. A lot of our information about our cities is actually indoors. It's not outdoors. So a cooperation between ETH and the city has been underway for a number of years. This is an image captured from one of their drones, Wingtra. It's a large UAV, over the city of Zurich in Switzerland. These are brought into reality, just like in the previous examples, and this imagery and LiDAR information can be processed into an accurate snapshot of reality, which is not only useful for the city, but also useful for an urban campus like ETH. So within this ongoing partnership, a scene like this can now be created. This typically consists of many layers created from different data sources. The schematic buildings and trees in the background are 3D object layers sourced from the open data site of Zurich. And this is brought in alongside information about the campus facilities, indoor information, looking at the rooms, the corridors, et cetera, that exist throughout ETH University. Apologize, video is missing. But for ETH, they had an urgent need. They needed a solution to provide navigation for people with disabilities across their campus, throughout the city itself, from building to building. And orientation in larger buildings can be very challenging. You can't really use classic signage. It's also very cost intensive. So what they did was they mapped approximately 55 buildings with ArcGIS Indoors, over 400 floor plans. And this was both from DWG and Revit, obviously, as a data source, but also reality capture inside the buildings and converting that automatically to floor plans, which is critical with older buildings, for sure. This includes points of interest, employee locations, and enables hot desking throughout. The result is a comprehensive indoor positioning and navigation system. This is a routable network, and it connects all of their buildings from the different campus locations within the city across the city as well. So if you're in a wheelchair, for example, you can go from one building to another and also calculate slope, for example, within the city sidewalks. And with over 6,500 beacons, the blue dot inside of these corridors is highly accurate to the meter. The last example today I'm going to take you through is Nottingham in the UK. This is a medium-sized city, about 250,000 in population, and they've been in the forefront of using a digital twin of their city for the review of major development applications. So they enable the document review process to be conducted with the submitted 3D models from architects. This is also well ahead of the traditional building permit process. We call it pre-application review. So in order to answer critical questions like, does the proposal follow local design guides? Which major planning applications are being approved across the city? And how many new student flats will be available? So within this experience, we provide out-of-the-box tools that allow you to bring that data in, understand that data, slice through these highly complex BIM information, and then analyze that information and create discussions around that information that all of the different case officers can take part in, and start to quantify that. So it's not only about the subjective review of will that proposal look nice, but will it cast a shadow on the neighboring parcel? And we do this across the entire city. So what you're seeing here is just one project. And case officers can go in, open individual projects, see the latest uploaded BIM information about that particular project, and even change status of that project on the fly. Now, in the past, you would have had to maybe have a license of BIM software like Revit or ArchiCAD, but now it's very easy to take an IFC file from a BIM software and export, and bring that information into the GIS. Essentially, architects know how to export their data, and cities, especially you in the audience, can ask for it as part of the development review process. And this data, in turn, can be uploaded into the map, whether you're using a mesh-based map or semantic-based map, and we can start to use that geo-information that they might have about a point on that BIM file. Usually it's given to you in an email, which is not uncommon, but that can be plugged in so you actually get a georeferenced result of that model. You'll see a bit more of this in the afternoon with some local examples. Now, the result is that Nottingham as a city council has seen a return of £2 for every £1 invested in this system. It's a third-party study, which can be found if you Google Nottingham ROI. This annual savings of over £20,000 for the review of major development projects is to the city council, but what's more interesting is they found that the system benefited the developers even more. The development community sees a net value of £40 per square meter. This is how they calculate it because they think of all of their developments in terms of square meters. But this is due to the reduced introduction costs, but also the reduction in the redesigns needed, especially in the very early stages of these very sometimes contentious projects. With site designs and master planning, their staff is also seeing time and money saved, and this is a very small team of planners, I think maybe 4 or 5. So they saw £55,000 of annual savings across 25 site designs, which is what basically happens every year. They also have a public-facing major development application. This is shared with the public. You can go and take an exploration of it today. This helps citizens understand what's being proposed and built nearby, and it's also helping developers understand new opportunities because development attracts other development. And what you'll see here, and maybe is not unique to Nottingham, but very important, is the pre-application stage of these projects. So this is the very early stage where they don't yet have a permission to build, but they're still willing to share these out to the public in order to gain a better understanding of the public sentiment on these projects. Nottingham has also been very forefront and taken on the new XR viewer that we've now released. This is in public beta. They brought this out for public engagement during their citizen consultations, and their urban model can be streamed into this game engine experience, just like I was showing you earlier with that BIM for Stuttgart's rail station. This has all of the different scenarios that we were talking about, so in this case, the Queen's Road that we were uploading, has the previous and the improved scenario, and it allows the staff to virtually place themselves on the street. Now, as you can see, this mesh is good enough to measure the height of the curb. And so we'll start to see these mesh data sets increasingly becoming closer and closer to reality itself. And this allows someone who maybe is not an architect or a planner to really put themselves on the ground and understand the impacts of these proposals and really take a walk down the street. Human scale. And I don't think our maps have ever been human scale before. And it's really going to take all of us to understand 3D cartography and 3D mapping at a whole nother level, like we do 2D. So ArcGIS is a system for 3D, data management, visualization, analysis, and app building. And this is from web to game engine. It's an incredibly powerful system of record. And as you've seen from all of my examples, it's fundamental for a digital twin. However, for you in the audience today, you may ask, where do I begin? Right? And it was mentioned earlier, Esri Portugal is in the process of building out an LOD2 3D base map for the entire country. This is based on 2024 national LiDAR data set, 50 centimeter in resolution, and about 90% of Portugal is available. You can use this data starting in Q1 of 2026, either as a public layer or it can be downloaded, making it easy to bring it into CAD tools or BIM software for architects, for students that are new to GIS. And here you can see the data being downloaded as GLB, for example. You can adjust the base point. Sorry, the video is paused just a second. Yeah, maybe click on the video. There you go. Perfect. And alongside GLB, for example, we natively support IFC, CityGML, FBX, USD, many more formats that are, let's say, very industry standard. Also now available to you, first in Pro 3.6, and soon for ArcGIS Online and Enterprise with the next release of Online, is the new Google 3D Tiles base map. So for those of you in the audience today that say, I don't have 3D, or I need my base map to be photorealistic for it to be useful with the audience that I'm trying to reach, this is for you, and this is an entry point, and as you can see, the model is beautiful. It's also global in coverage, meaning, yeah, it's not just the major cities, and it works with all of our out-of-the-box tools, like the scene viewer, which I'm showing you here. Within the scene viewer, you can navigate to points of interest, for example, and we've built in these tools that, just like in 2D mapping, we learn about symbology, cartography in 2D. The same thing with 3D. We're developing these tools to allow you to start to tell a story, to really make the work that you do more impactful, more immersive in this environment. And as I mentioned, it's global in coverage. So here is a view of that Zurich data set. And it's not to replace your existing 3D mesh. It's certainly not a Gaussian splat layer. But this is a starting point and offers complete coverage similar to imagery-based maps in 2D. Right? This is an imagery-based map, but it's 3D. And you can start to input your higher resolution data as you need within this environment. I will conclude with this, that location and GIS is the ultimate integrator of digital twins. And digital twins can play a very big role in future-proofing our cities for whether it's planning or climate resiliency. And we have the best technology here today, which you've seen all morning and also will see here in the afternoon. But what we really need to do, and this is a call to you, is to connect the different professionals around these different use cases that could really utilize not only the data, but the tools, and bring this data and these tools across, getting everyone to speak a common language, which is GIS. Obrigado.